Hi guys, I just want to introduce this video a little bit so you know what's going on, because otherwise it would be really weird and confusing. But I'm talking to Jeff and Charles. They're the electronics engineers working behind the scenes on the Fockbox Unity. If you don't know what the Fockbox Unity is, it's basically two Fockbox motor controllers joined together. Jeff is he works at NASA at the moment. He's a PhD student on a NASA scholarship or something. But anyway, he's been working on this dual Fockbox, and we're doing all sorts of tests to see the performance. And yeah, check out this video. check out this. Check out this video. We'll show you a little bit of behind the scenes of what we do to develop this stuff. He's back.
Hello.
Jeff, what's going on, mate? I've heard a rumor that when you're doing a PhD, you basically live in the lab. Was that you telling me that, or?
It wasn't me, but it is generally true.
NASA. Can I film NASA? Just show me. I'm filming this. Can I film NASA's shit or what?
Yeah, I guess so.
There's secrets. There could be secrets on your back wall there that I'm not meant to share.
No. All of our stuff is shareable, luckily.
Can you show me that robot again? Just tilt the thing around.
Yeah, sure.
What the hell is that, man?
That's like a second generation robot. It's called Superball. It's like concept designed for a planetary lander robot. The idea is like there's a continuous tension network with rigid elements, and basically we call it Superball because you can just forego a lot of the landing equipment and just fall and bounce on the ground.
So fully like protect the equipment that it's carrying or whatever.
Yeah, exactly.
Yeah, one of those. That'd make the perfect crash helmet.
Yeah, my new concept design for a crash helmet.
That wouldn't look weird at all. That's what you NASA guys do, right? You just build robots, put it on your head, sit around.
Yeah, mostly. Ask for money.
So sorry, Charles. What have you got on your screen there?
You know, guys.
Fuck yeah.
Is this me?
Yeah, it passed. Yeah, baby.
That's the sound I want to hear.
Oops.
Final cord.
Nice.
This is just a model.
Yeah.
This is a sticks and stones model, but we have some of our guys over at Berkeley built this in like a robot form with actually like actuated cables, and they put legs on it. We're able to like make a quadruped with a flexible spine, which is kind of something new.
Yeah.
But it doesn't work very good.
Just.
Yeah, this is how I got started on the whole motor driver kick. I bought one of your Fock boxes, and I was doing some cable control of this big brushless motor.
Yeah.
Works really good.
Just to satisfy my desire for knowledge about robots, what's the current best joint technology? Is it like to move things, cables, or like pneumatics, or motor, direct drive, or is there just a combination of everything?
It's definitely not cable driven because it's just not quite there yet. Like, there's more technology that needs to be developed to do it, right?
Yeah.
There's some really fancy pneumatic ones. Like a lot of the old Boston Dynamics videos where you see like that giant robot dude, those are mostly pneumatic.
Yeah.
But they're new. After Google acquired that company, now they're moving to like all kind of like direct drive, brushless motor type stuff, and or like like with like some complicated linkage mechanisms.
I'd love to have a chat to some of the motor designers that are doing the direct drive joint designs.
I'm going over to Google Robotics in the next couple of days up with my friend. I'll send you a video of the robot he's working on.
Yeah.
But it's really cool. Yeah, basically like motors like this. and each leg is like a little 4-bar linkage, and the thing's crazy, like jumps all over the place, climbs fences and stuff. Super cool.
Yeah, it's getting impressive. Anything different than sort of what we're working on, or is it basically the same stuff?
I think they're worse, honestly. The only thing that's better than what we have is just that they're running like EtherCAT, which is just a communication interface, but it's like kind of fancy, so you could run it really far and stuff, and it's like super robust. But other than that, like I was talking to him about his motor controllers that he's using. They're lower power. They only go up to like 24 volts, and they're like running it black box, so they don't have, it's not open source, so they don't have like control over the firmware and stuff, so they have to run everything like a level up from the motor controller, which limits you in some of the things you can do.
My favorite one at the moment is the one that does the backflip, Boston Dynamics. Backflipping robots and all that, and we can't even have decent video conference calls. So what's been going on, man? You been doing some late nights or what?
Yeah, I've been working like crazy to get all this stuff working. Yeah, I have the motor config basically working. That page is good.
It'd be awesome if you could run like a test sequence that just tested what a battery was and gave you all the answers. I mean, what is the information that gives you, your like maximum current discharge based on the chemistry?
Yeah, because it's wildly different. Like even if you have lithium ion and you have 18650 cells, right? Like if you have Samsung 25Rs, we can do 20 amps continuous per cell or 15, to be safe. But if you have like NCR 18650Bs, we can only do like 5 amps per cell or something. So it's like, and then that's just within lithium ion, because you could also have, you could do lithium iron phosphate, you could do lithium polymer. If it's lithium polymer, you can pretty much just do any current you want.
Yeah.
I think it would be like, at the very least, you definitely want to do like series cells for the voltage cutoffs. The next, like, there's basically just 2 settings that you really need to set. It's the minimum voltage and the maximum current you can drop on the battery safely.
Yeah. Hey man, how's your internet, bro?
No, still shit. I think the whole architecture needs to change a bit. Maybe that's a little risky for now.
Yeah, that was the only thing, is we could do it, but it might cause a delay if we fuck something up.
Yeah. So if we want to implement the Unity in the Raptor 2, we need to change the switch. We could still stick with the rocker switch. However, we need to flip to the double pole switches, because right now we just have on or nothing at all.
Yeah.
So that's fine. I mean, it's not a big deal. And at the same time, we need to change it. Need to put change the connector on it. That's fine also.
Yeah.
If you use the same BMS you're using now, which has the power switch on it,
yeah,
then you just either just open, drain the. You just leave that switch locked open. You don't need 2 power switches.
Yeah, exactly. Well, that's it. We would get rid of the switch on the Raptor, but then you'd be losing the fuse. So yeah, that's something we have to think about. But yeah.
Yeah, I think it's just gonna be a bit of a different.
Anyway, I don't want to rush implementation into the Raptor 2 just yet. So.
No.
Yeah, I think like you guys have something that's working, so it doesn't make sense to like immediately.
Made too many goddamn changes with that product. I just want to build it,
Yeah, exactly. Exactly. Cool.
Yeah. I'm a little, I don't know, I don't want to, like, I opened my Raptor up and it just looks so good in there. I don't really want to, like...
Start pulling it apart?
Yeah. Because I have another board now, too, but I'm running, like, lower power motors, so I can't really test the...
Well, we could ask Barrow, see, maybe he has a refurbished one.
Yeah. What do you need? You just need motors for bench testing, is that what you're saying?
Well, I want to, like, just slap it on a board so I can just haul ass up a hill to get, like, the full power, full heat kind of situation. Because the motors I have, I think if I run them over, like, 30 amps, they're going to just melt.
Okay. Basically, you need a test Raptor. I'll see if I can get you one.
I don't want to cut
the
my
test Raptor.
It looks so good.
That's the story of my life.
Yeah.
Test Raptor. It's always in fucking pieces.
Yeah, Yeah, I mean, I've been using it to just commute and stuff, and I don't want to like mess it up, and then I'm like stranded somewhere.
Nah, it's totally understandable, man. You don't want to start doing that. I mean, I think I'm the best person to understand. I don't have a board. I never have a board.
Yeah.
I'm a fucking a shoeless cobbler.
But yeah, I just need motors that can handle like 60 continuous amps, and then I'm gonna find the steepest hill I can find and just like see what kind of current I can put through the board. That's what I want to find out.
I think at this point, what we're most concerned about is heat management. I think from the motors.
After I would take them up a long hill, and it was toasty.
Yeah. I mean, there could be a point where we decide that there's a maximum current amount that achieves maximum performance, and anything above that is just wasted energy, you know what I mean?
Yeah, I mean, that's essentially true because it's one of them scales linearly and the other one's scaling quadratically. So, like,
yeah,
for 60 amps, right, your torque goes up twice 30 amps, but 4 times energy wasted. So
yeah, so then it'd be cool if you could measure that somehow, like when you're setting motors up, somehow.
What you're essentially doing is you're creating like an optimization problem, and then it's like a cost function. And there's like 2 competing things, right? You want it efficient, and you want it performance. And so then, like, it just depends which one you want more.
Yeah.
Because they always fight with each other. Yeah, that was one of the reasons why I'm thinking like it could be cool to throw like, you know, if you throw like an accelerometer on the board, inclination angle, and then when you know that inclination and they're like going uphill, you can calculate based on average power. You can actually know exactly the weight of the rider, for instance.
Yeah. Did you end up 3D printing the lid and stuff?
Oh yeah, it's literally right here.
Yeah.
It doesn't look the best, but
Yeah. You need to tell NASA to upgrade to that SLA stuff, mate.
yeah, like an aluminum printers and steel printers and all kinds of crazy
Really?
shit, but you got to know the right people and fill out a lot of paperwork. You want to do about on the bottom outer rim of this thing, it's all 1 millimeter around that little lip you added.
Yeah, I don't think that's going to be an issue in terms of molding it.
Yeah, it's water cool though.
Yeah. Magnetic liquid?
Oh yeah. Ferrofluid.
Ferrofluid, yeah. That's what all the e-bike guys are doing in their hub motors. And they're leaching the heat out of the windings into the rotor, and then they're putting heat fins on the rotor to cool it. So
yeah, see that's true. Like imagine if you could actually, it doesn't have to be freaking ferrofluid, but like you could fill it with just a heat conductive fluid and lock it in. That would make a huge difference too, because then not only are you getting, it's not just the thermal conductivity of the fluid, it's also that you get then like convection in there.
yeah.
The only thing I'm thinking is like the ferrofluid. I'm like, what? Like because that they're called rheostatic actuators. We use them in robotics sometimes. They're basically just that's what they are. They're big copper windings and a ferrofluid thing, and you can use them for like it's called rheostatic braking. What you do is you generate these like magnetic fields, and it actually those videos of like people playing with ferrofluid where they like make those like crazy spiky things and stuff. That literally happens like inside the motor. These like magnetic columns of iron get built, and it slows down and adds a bunch of friction. So I'd be surprised if that wasn't happening when they did that. But,
So actually causing some kind of resistance.
yeah, it's super possible that that's happening. The only good thing would be you'd increase your like flux density. But imagine you could do instead like you can even do like a non-conductive fluid like mineral oil. It's pretty heat conductive. You could just fill it with like a mineral oil or something.
Yeah.
And then seal it. If you had to seal your motor, maybe that's better than just air in there, because air is like one of the least thermally conductive things you can have.
Yeah. Yeah.
One thing I noticed too that you tell these brushless motor guys, they were putting, this is the thermocouple that's inside the motor.
Yeah.
And right now they were bonding it PCB. And that sucks. It's like it's literally going to be no different for them just to glue it the winding, because we'll get like a much more useful sensor reading.
Yeah.
If they put it to the copper. Yeah, and like the closer we can get to knowing the winding temperature, the more safe we can make the motor. You can push more power, right? Like right now, you might current limit to 60 amps, right, or something. But if you actually know the winding temp, you don't even have to put a current limit. You can just like, you can go, oh, my windings are getting pretty hot, back off a little, or something like that. You know?
Just go maximum current until a temperature, and then step it back. But then when you truly want performance, then it actually does come back to cooling, because if you are gauging your performance by temperature, then you just want to keep temperature as low as possible to keep performance as high as possible.
First of all, there's two main things, right? How much heat you're going to introduce into the system, which is going to be completely dictated by, first of all, your motor controller efficiency, which is pretty much maxed out with field-oriented control. You're not going to do much better. The only thing you can improve is like, if you got a faster microcontroller and increase the PWM frequency, you could eke out another like 2% efficiency or something.
Yeah.
But like, stupid, not going to work. The next thing is all about like motor design, right? You want to get the winding resistance as low as possible and the motor kV as low as possible, and then you just use more motor voltage to like compensate for that.
Yeah.
Especially because, right, like the Raptor 2 goes so damn fast right now that no one even like needs to go that fast. I don't think.
No.
32 is pretty scary. Those are the two main things, right? Because that's the amount of heat that's going into the system. And then after that's in there, and once you've optimized all that stuff, then the next part is just like, how much heat can I take back out before things get too hot, right? Like, I think what would make a much more dramatic difference is if you could like texturize the wall, the metal wall of the motor. That would be a great interface to get heat out of the motor. If you could get turbulent air passing over the back of this motor. For instance, like what you do is, like you could take this truck and you put like a thing here that's almost like a cover, plastic even, like an injection molded cover, and then inside on this motor you put like ribs. I don't have a good fan here. I'll send you a link after this.
Yeah.
Like what I'm talking about. But you can put like fan fins and do like a little inverter fan on the back plate of the motor. And then what that'll do is it'll suck air in, blow, and then it's blowing all this air over the fins of the motor.
Yeah.
And then out the other side, and you get like a much higher wind speed over the steel that's connecting to the motor.
Yeah.
Drastically increase your convection coefficient, which will like double the heat you take out of the motor like that. That would probably be like, and the great thing about that is then it'd be a little bit safer too, because you wouldn't be heating up the trucks quite as much.
Yeah, in my first motor designs, I had like features inside the motor to increase turbulence. So as the rotors, and I once again, no mass to back it up, but I figured if you can move the air more turbulently around inside the motor, that could also do something. But then the cost of machining those features inside the wall of the motor was just stupid. So I said, look, don't worry about it. But
like whistling or something, that would be terrible. Whistling.
Could be entertaining though. Really high pitched.
After the first 100 miles later.
Make it replicate the noise of a board.
Oh God.
Yeah, I don't think they know how to fix it.
Well, you can't. That's why people don't use planetary gears and
Yeah.
stuff like this. Like we have all these robots over here with planetary gears. You know what they sound like? Like yeah, they're fine. They'll work, but they're not gonna not annoy the shit out of you all the time. Like,
I mean, I think direct drive for me is the most exciting area. I mean, belts and pulleys, it's sort of like anyone can make that work. I think the real exciting area is optimizing motors and like the discussion about how to cool them the most efficiently and how to get the most performance out of them. You know, that's what really I'm interested in the most.
I really want to do a bigger wheel.
Yeah.
Like a big, almost off-road wheel, but like on a big pancake motor. Off-road wheel and just...
Yeah, I started designing it quite a while back, and the Raptor 2 has just taken all my time. Yeah, I built one myself, and surprisingly very, very good performance. And they didn't even get hot. We were going up the steepest hills, and they weren't even like optimized for that application or anything. So yeah, huge potential.
Yeah. The roads around freaking this town that I'm in are just trash, so I'm like keen on getting some freaking bigger wheels.
Yeah. The thing is with people with all-terrain, there's this like division between people who want to like have bindings and go off jumps with it versus people who want like an Evolve all-terrain which can't go off jumps. And
I think like what I would be keen on seeing, what I think would be like a more widely appealing product, because like people aren't gonna fucking ride a mountain board and take it off jumps and shit, like, or like not a lot of people.
yeah.
Because they just aren't athletic enough, you know. I think like it's what's the most appealing about it, right? Is like I watch a lot of reviews on like the Evolve boards. They're talking about like, yeah, I just ride always with my all-terrain wheels. It's just a smoother ride, you know.
Yeah.
And that's what people like. They just want to have like a smooth. Because like, yeah, I definitely get like a little bit of stress sometimes on a Raptor 2. So I'm like, fuck, like rock, like I gotta like.
Yeah.
If I didn't have to think about that, though, it would be pretty nice, you know. Like, yeah, when I'm on a smooth road, it's great, but
Yeah.
a lot of people live, you know, like a lot of people in Europe and stuff, a bunch of really old towns, roads and shit. They probably can't even use a Raptor 2 to commute because it's too rough. You know?
Yeah.
It'd be like building boards that could just focus on getting a smoother ride on like a slightly rough terrain. Not like, yeah, maybe like mountain boards, almost the wrong word, but that's kind of what I think would be like super appealing to people.
Yeah. I got a few ideas for that, so, you know. Okay, man. I'll try to get you a test rig.
Yeah, that'd be great.
Cool. See ya.
Peace.
Okay, thanks for watching that, guys. I hope that gave you a little bit more insight into what it's like to develop products and the testing and the endless hours of programming and testing and all that stuff that goes into making a product. Now, you all want to know when the Fockbox Unity is going to hit the market. Maybe soon. That's all I can say. But Jeff, the guy I was just talking to from NASA, is going to be in Australia in like 2 weeks. He's got some robotics conference on in Brisbane. We might go to Brisbane. I don't know. We might go to Brisbane. He might come here. Anyway, we're gonna meet up with him. You'll get to see him in the videos in person, and we'll talk to him. We might do a Q&A session. I don't know. We'll do something. Anyway, thanks for watching. Don't forget,
subscribe,
like and comment on this video.
it helps us.
See you later.